it like an AED machine. It has a capacitor of 100 microfarads, and it's charged to a potential of 1500 volts. When fired through a patient's chest, it loses 95% of its charge in 40 milliseconds. So this is an RC circuit where there's a capacitor in the defibrillator, and the resistance is the patient itself. So what we know is that the capacitance is 100 microfarads, 100 times 10 to the minus 6 farads. It has a net potential of 1500 volts. Delta V0 is 1500 volts. It discharges over a time of 40 milliseconds, which can be written 0.0400 seconds. And the charge it has after this time is 95% less than the initial charge. So it's 5% of Q0, or 0.05 times Q0. So we know that we have a change in charge. Let's write down the expression to find how the charge changes as a capacitor discharges. Q is equal to Q0 e to the minus t over tau, where tau is the time constant, R times C. Let's fill in about our Q's. We're down to 5% of Q0. So we'll fill in 0.05 Q0 for our Q. The Q0 cancels on either side. Let's remember that tau is R times C. We want to find our R, so we need to get rid of the E. We'll take the natural log of both sides. Then we can solve for our R. R is equal to minus T divided by natural log of 0.05 times the capacitance. So minus 0.0400 seconds divided by natural log 0.05 times the capacitance C, which is 100 times 10 to the minus 6 farads. And we get for our resistance 133.5 ohms, or 134 ohms when rounded to 3 sig figs.